So I'm just kind of hanging out like we're casually talking. That's right there.
Got some coffee there?
Tea.
Tea. Oh,
Refined.
nice. Hey everybody, thank you for joining us today for SketchUp Live episode number 8. My name is Josh, that's Aaron over there, and we're also joined today by our colleague Hari, who helps architects design more energy efficient buildings.
Hari's going to give us a look at Sefaira extension for SketchUp. I'm going to let him explain exactly what Sefaira is because he makes it sound a lot better than I can. But as we're going through here, you have questions on energy-based design, daylight analysis, Sefaira in general. Go ahead and send them to us in the comments. We have a couple of our coworkers, Niraj, Rob, and Joy online to help answer your questions as they come in. Welcome, Hari.
Oh, thank you, guys. What is Sefaira? Sefaira is a software that works inside SketchUp that helps architects design high-performance buildings right from the early stages of design.
That's awesome. That's something that we actually hear a lot of requests for, is doing that design work. And the fact that we can do it right inside of SketchUp's got to make that a lot easier for people than manually calculating energy. Well, can we hop in and just take a look at it?
Sure, yeah. So the whole idea of it being in SketchUp is that's where they're designing, right? So what we envisioned is that there would be this little GPS kind of thing to the left that kept telling you how you were doing as you designed. But before that, I also want to say that there's not much design that needs to happen before you can start understanding how your building is built.
So this model you have up, there's nothing, I want to say the word special about it. It's SketchUp, so it's very special. But there's nothing complex. You don't have to go through a bunch of weird hoops to say this is an energy model, correct? It's just it's a pretty simple model, really.
Oh yeah. All that we need is the basic idea of the building shell and the inside, right? Which is just walls, roofs, floors. If you notice, they're all single plane. There's no need for window frames or anything. So just enough to tell us what's a window and what's not, basically what's transparent and not, and all the other planes. Once you do that, Sefaira knows what it is.
So Sefaira is the model you create for this energy design is intended to be very basic, simple, quick. That's looking at that's minutes of design to get that concept of a building in that you can start designing for energy.
Yeah, so you don't start like you might normally start drawing a building in SketchUp. It's a very focused, preliminary type of structure.
Absolutely. Yeah, for a few reasons. The first is, at this stage, for analysis, more detail does not mean more accuracy. So you don't need to put it in. And we figure that whatever it is that you're designing, you're going to pass through this stage of it anyway. So we might as well help you while you're in that stage.
Yeah, right. Do it at the beginning.
Yeah.
That's awesome. All right, well, let's see how energy efficient this building is.
All right. Oh, also want to show you that Sefaira knows what's going on, but it will also tell you if you ask it. So it will tell you what it thinks pieces are.
Whoa.
Yeah.
Color coding.
And it assigns this stuff automatically initially, right?
Yeah, it takes a first pass and assigns everything, but it's not set in stone. So if you want to change things, you can change them by right-clicking and going to the plugin and tell us that anything is anything else.
So it makes its best guess.
Yeah. It'll also tell you how many of each thing it found. So that way, if you're wondering, well, I should have 10 floors, but I only have 9, you can find that out.
Okay. That's great. So it's, automated. You don't have to go in. You didn't go in and tell it those things were walls. It figured that out itself.
Yeah.
That's awesome.
All right. So now we have a building. Sefaira knows what it is. It's exactly what the architect or designer thinks it is. So what else do we need to figure out how this building performs? Sefaira will ask you a few questions. It'll ask you what kind of building it is, so that way we know how many people are in it and what the operating hours are. Then it'll ask you where it is, so that we know what the weather is like and what the sun is doing. Now, once we know these two things, Sefaira will automatically make assumptions for everything else. What the building is made of, what's inside it, what kind of systems it uses. And we know this from standards. So the idea is that once you tell us these few things, we will get you started off with a code minimum building appropriate to your location.
So again, just like the model is simple, it's quick, that's setting up those design conditions is really a matter of what is it and where is it, and that's
Yeah.
it. You don't
Yeah.
have to go in and specify a huge page of
Yeah.
properties or anything like that.
Absolutely. But if you really want to do that, you can. You can tell us individually what each of those things we need to know are. And all this
Okay.
is what is the building made of? So what are the assemblies? What's inside it? And some system stuff. So you can tell us that, or we will make assumptions.
That seems too easy.
Yeah. But the idea is that we don't want you to spend too much time while you're designing, researching things that you might not know at this stage or have to go somewhere else to find.
Okay,
Right?
that makes sense.
And once you do that, we will tell you a few things. The first thing is, how much? What's your miles per gallon for energy for this building? And the number we use is the energy use intensity. That is the annual energy use of your building divided by the total square footage for one entire year. It's one number, so it's easy to track. It gets you started, and once you make changes, you know if you're getting better or worse.
Okay, so a barometer for energy efficiency.
Yeah. We'll also tell you the next stage. Well, we know what the energy is, but where is the energy going? So that way you have an idea of what is consuming energy in your building and where you need to start with optimizing this building. So here we see that heating is the largest load. You have some cooling, and those are the big climate comfort related things. Apart from that, you have a lot of lighting and some equipment.
Okay.
So this is the big things. And we'll tell you, you don't even have to look in here, we'll just tell you right off the bat, heating dominated, which means that heating is your largest energy use.
Big red letters are a great way to get issues across like that. So this you refer to this as like a GPS like. So
Yeah.
this is basically right off the bat without having done anything. Here's how your model is performing right now.
Yeah.
And you literally didn't do anything at this point.
No, I did not.
Not to undersell you, Hari.
Yeah.
Okay, so this? There's lots of colors and things, but what is this little? Looks like two squids wrestling down at the bottom.
Yeah. Now this is my favorite part of this, and I find that this is the most valuable to the designer. So this is where the energy is going. That's what we saw before. This is what is driving that energy use. It's what's happening in your building that's making it consume this energy. So how we've kind of arranged this is the blue part is your cooling load, which is the amount of heat you need to remove from the building to make it comfortable. And the red is your heating load, which is the amount of heat you need to add to the building to make it comfortable. So because this building is in New York and it's more cold than hot there, you need more heating. So we already know this is a bigger driver than this. We've also color coded it to show that things in pink are adding to your load, so that's bad. And things in green are helping. And you'll find that sometimes things hurt you and help you at the same time. Right? So depending on the time of day or the month of the year.
And because this is a snapshot of an entire year,
Yeah.
sometimes it's good, sometimes it's bad.
Yeah.
Okay.
So what are we seeing in this building? Well, it's a leaky building, which is okay in summer, but it's really bad in winter because you're heating all that air up and it's leaking out. Wall conduction, this is the R value of your walls, which means that this is the heat you're losing because it's either hotter inside or hotter outside. If it's hotter outside, you're gaining heat, which means you need to cool, which is what is happening here. And if it's hotter inside, you're losing heat through the wall. That's what this is saying. So that's a bigger problem for you for this building in New York in winter than it is in summer. And glass, right? You're losing heat through the glass. You're not gaining too much heat through the glass. So the glass has almost no effect in summer. You might want to look at your glass in winter. And finally, the sun. The sun is adding to your cooling in summer, but it's helping you in winter because it's getting or putting that heat in that you need. The other important thing is you don't need to care about any of these other guys. That's what we're trying to tell you here too.
Yeah. So pretty helpful hints as you start to design and figure things out.
Mm-hmm. Yeah. And if you're here and you've seen these and you're wondering, where to go, Sefaira will actually point you in the right direction. So heating is your largest. Heating is your largest load. Here's what you could do.
So these are links to just basically tips on how to address those issues.
Yeah, and
That's awesome.
and they're by the AIA, so they've been tested.
That's great. So at this point, if you wanted to address some of these issues, you'd have options. Obviously, you could change the model.
Yeah.
You go in, SketchUp preliminary model, change your window sizes, something like that. Are there other things besides the physical that you could adjust to address your heating?
Oh yeah, yeah. In fact, you can either change the geometry, which is why you're in SketchUp, which is great. But let's say you really like these corner windows, and you want to keep them the same size and shape. You can actually change their properties here just to see what would happen. So you could go in here and say, I want my glass to be slightly better, maybe more expensive, but I like the way it is, and we will recalculate and tell you what happens if you did that.
Wow.
Yeah. So there's quite a bit that can be done here with not just geometry, but also with parameters.
That's great. That's awesome.
Don't forget to ask questions. If you have any, please let them loose.
Yeah. We're going to run out of stuff sooner or later, so we need you. Please help. That's awesome. So can we take a look at creating a model from scratch? I know this is a cool looking building, but what would the steps be like if you were going to go in and just create a model? Can we do something like that?
Oh, absolutely, yeah. And all right, let's get rid of the innocent bystanders.
Hi, Chris.
So let's say you have a brief and you're initially deciding, well, maybe should this be a 10-story building or should this be a broad 5-story building or something like that. So here's what we would do. So let's say
Just using the rectangle tool to just create a surface on the ground.
Yep. There's no special drafting that needs to happen. All right.
Push pull.
Uh-huh.
Just showing that there's nothing up Hari's sleeves right now.
Uh-huh.
Just okay.
Yeah. So
take that plane and just come and offset it up 9 times.
all right, and let's throw some glass in there.
So all you're doing right now is just using the line tool to break the surfaces.
Yeah.
Getting crazy.
Uh-huh.
Awesome.
Yeah. All right. And now we're going to tell it that it has glass just by applying a transparency to the glass surfaces.
Okay, so not actually like setting a property or anything like that. You're literally just painting on a material that has less than 100% opacity.
Yeah. And that's all we need.
That sounds totally doable.
Yeah.
So at this point, Sefaira is ready to figure out what those are and then do its initial design based on, again, it being an office in New York.
Yeah. In fact, let's see if it figured everything out, which it did.
So there's glazing, wall.
Yeah. All of that.
Wow, so it just figures that. Is that just geometry based on it being a vertical plane, it's a wall, that sort of thing?
Yeah. Let's add another piece of glass here.
For symmetry's sake.
Yeah. Also, otherwise, that's where they'll send all the interns.
Intern corner on the first floor. I like that idea.
Yeah. Oh, in fact, this is a very simple building, right? If it was slightly more complex and you're trying to figure out, well, did I get all the pieces that I needed? We can actually isolate those. So here's all the floors only. Did you get them all?
Wow.
Yeah. Once we do that, how is this building doing? Well, this is a glass monstrosity in New York with 15-foot floor-to-ceiling height. So it's consuming quite a bit of energy, and it's got a lot of equipment in it. So, well, the whole, did this take like a minute?
Yeah, roughly. So a question about that. So you said, by looking at it, obviously, this first dial here on the left, it's red. So I'm assuming that's not a good thing. There's a little green line on there. I'm assuming that's a goal?
Yeah. Oh, so what we did was, we found that a lot of architects wanted to know how they stood as far as the AIA 2030 challenge was. So what would their energy use?
I have a question. What is the 2030 challenge?
The 2030 challenge is basically a design challenge for architects to bring all their buildings down to net zero carbon by the year 2030.
Okay.
And since
challenge.
energy, since energy is the biggest hog of carbon, that's why we want to attack it this way. And so for this building type, size, and location, what would the score have to be for you to hit that target?
Okay, so that's that green number 29 is what we're shooting for. We're currently at 41.
Yeah.
I understand.
Yeah, so this building is winning no awards. So
Very cool. So when you talked about that design, so if as we were talking right through it, a design or something analysis happened. You said it took about a minute. What exactly is that when you say an analysis? I mean, what's going on?
So what Sefaira is doing, and it's using an engine called Energy Plus to do it. It is basically taking the building, looking at the weather, and running an hourly simulation for an entire year of how much heat is coming in, how much heat is going out, how much heat is already in the building because of equipment and people and stuff, and then adding it all up and giving you these graphs. That's what it's doing.
Okay.
So 8760 hours of analysis.
That was fast.
Yeah. That's because we don't want to do it on your machine anymore, because that was a huge bottleneck for people to actually do this. So it's all in the cloud.
Ooh,
Yeah.
Cloud.
that's a buzzword.
Yeah.
All right, so what we're looking at right now, it actually says that the analysis is out of date up at the top. Can we reanalyze it real quick right now, just to get an idea of
Sure.
what that's going to entail?
Oh, in fact, let's make a huge change. Let's say this office is like super efficient, and everybody, maybe it's an architect's office, and everybody does everything manually with no computers, right? So we reduce the
That's how
amount of
architects work.
So we're making a change to the insides to see how responsive this building is to the envelope if it had no equipment in it.
You mean there's no SketchUp happening in there?
Huh?
There's no SketchUp happening?
They go home and do that.
Okay.
They bring it back in afterwards.
They charge their stuff at home. Yeah.
Okay, so this is where you're saying this is running out to some server somewhere,
Yeah.
running some back end stuff,
Uh-huh.
and all it's going to do is deliver those results back to us. So we don't actually, it's not running the design on your computers, you're saying?
No. All it's doing is taking the geometry, sending it to the cloud, and then all the conversion to Energy Plus and analysis happens there.
Wow,
It's quite a cloud.
Uh-huh.
Nice.
that's awesome.
Yeah.
And that was like less than a minute.
Yep. And once you remove all the stuff that's generating heat inside, if this was a building that had nothing in it, heating load greater than cooling load, still quite a bit because we have so much glass.
We're closer to the green line though.
Uh-huh. Yeah.
So, I mean, just for fun, since we're doing this, what are the kind of things that could, obviously getting rid of the glass, but that wouldn't be as fun. What are some other things we could do to this model to account for all that glass? I mean, can we add anything else or manipulate the model somehow?
Oh, yeah. So let's take a look here again. Solar is your biggest contributor to the cooling load. It's helping you in winter. So if you reduce the amount of sunshine you get in summer, it's going to bump up your heating. But and this is New York, so you're probably using electricity to cool and using gas or steam or something like that to heat, or fuel, in fact. So in that case, well, maybe you'll save more money by working with the glass. So what can you do? You can have lesser glass, you can have better glass, or you can shade the glass.
Ooh.
Yeah, so,
I like the way you said that. I want to see that happen.
all right, so let's do something outrageous, like a 10-foot shade on every floor. And we're not just shading the windows, we're also shading the walls. So all you need to do is tell Sefaira that this is a shade,
Okay.
and then copy it down.
All right.
And this is on the south. So Sefaira knows that the green axis is north, so we are doing it only on the south because that's where the problem is. So let's see.
Let's analyze it.
Yeah.
Something else, just while that's running, we right now have this set up as office. The examples you're showing are big office buildings, but it's not just for commercial, right?
No, it's for, you can do it down to one room if that's an issue, yeah. We find that one more thing we didn't talk about is it's not just energy, it's daylight. So sometimes we have designers use it only to find out the daylight quality in one room. Sometimes people use it for energy.
Okay.
Yeah.
I got a question from Robert. Let's see what he is curious about here. Robert's asking, how do you distinguish the building thermal envelope versus other elements? For example, unheated attic, where the floor of the attic is the insulated boundary, not the roof.
In that case, what you would do is, we care at this stage, at the early stage, we care about what is conditioned versus what is not conditioned. So let's say you have a roof and you have an attic and everything above the floor of the attic is not conditioned. You would tell us that the floor of the attic, let's say this is right now a roof, right? You would, but if this was the floor of the attic, you would just say that that floor is shading. So as far as we're concerned, a shading plane is adiabatic. There's no heat that passes through it. All it does is stop the light. So you can tell us that that's adiabatic, and that will simulate a well-insulated attic floor.
Okay.
Yeah. If you want to get more, let's say you have a certain amount of insulation you want there, there's a whole other place in Sefaira you can go and get that detailed.
Cool. All right, so we did the design. What did the shading do for us?
What did it do for us?
So close.
So the shading reduced your cooling, bumped up your heating, so it was a net wash-ish. But you saved money.
Well, that's a plus.
And if you notice, South Solar, which used to be a #1 problem for cooling, has gone all the way
Drop
down.
way down.
Yeah.
That's great.
Pretty easy fix.
Yeah. That's awesome.
Yeah.
All right. Well, you mentioned daylight analysis.
Yeah.
Is that something you can show us too?
Absolutely.
All right.
So let's say you're working on this building, and at the early stage, well, right here, you're not worried so much about daylight because you don't even know what's going in the building. But let's say you're back at this point. Building's taken shape, you have windows, you have rooms, and now you're wondering about what the daylight quality is. So here's what we do. We will give you daylight information at various levels of detail, right? We'll start big and then gross and then start tuning it down to where you can make decisions. So let's take a look. So here's what we do, right? First, we tell you how you're doing for the building as a whole. So for the building as a whole, how much of the building is well lit, how much of it is, has too much or too little. We'll tell you that, which is a good. It's a good idea. It's a good thing to look at to find out if you have enough windows or not for your purpose or things like that. After that, we will tell you where on each floor do you get too much and too little for the entire year.
Wow.
And
so this is not light as it contributes to like heat or anything like that. We're just talking about visual sunlight coming in.
yeah,
Blinding me at my monitor versus sitting in a dark hole with the interns, that kind of thing.
yeah,
Okay.
yeah. This is pure daylight for quality purposes.
Okay.
Yeah.
So as this is coming up, it seems like kind of a, I don't know, subjective term, well lit versus overlit. What makes something well lit versus overlit versus underlit? Is that just like, is that a slider, or how do you decide what that is? What does that mean?
So we use metrics from LEED.
Okay.
LEED is Leadership in Energy and Efficient Design, and they have a standard that says that this is how much you should have if you want to do work, and this is how much is too much. And so the number that we use for how much you should have is called the spatial daylight autonomy, and that is the percentage of your floor plate at the work plane, so about where a desk would be, 2.8 feet, where you get at least 300 lux. Now 300 lux is the usual lighting level in an office. So do you get that from daylight for half of your operating hours? So half the time you should get that much, and that's as little as you should, and that's the minimum you should get. We also have glare metric, which is anything above that is too much, which is the overlit, and that is the annual sunlight exposure. this is again percentage of your floor plate at table height, where you get 1,000 lux, which is, I mean, you don't need it unless you're a goldsmith or doing something really fine. And you get that for 250 operating hours of the year. And that stuff adds up quickly, because even if it's 1 hour a day, it adds up really quickly.
Yeah.
Okay. So that analysis came back.
Something interesting happened there.
So
Colors.
Yeah. Oh, so the yellow is too much, the blue-black is too little, and the gray is just right. So you can look at this as only on each floor you can compare one floor to the other. But where this becomes a decision-making tool is when you start seeing why this happened. Which windows are contributing to this light? What are my shading elements or my context buildings doing?
And this isn't actually, we're in the extension right now. This isn't the SketchUp window, right?
No,
So
this is the extension.
because we're compressed to a single screen, we're overlapping, but ideally you could actually have this up with your like 2 monitors, something like that.
Oh, yeah.
That's pretty cool.
Oh, and why you would do that is because what you see here is directly in SketchUp screen. So if you move this building around, you want to look at it differently, that will change.
Ah, that's awesome.
So you get to decide your view in the most comfortable way you want it. And why would you do this? Well, now you know, for example, that, let's go back here and tilt it up a little bit. These big plate glass jobs are really adding to too much light, right? And so is this big patch. So now and also the other thing it's telling you is that these buildings on the north and the east are actually shading you from direct sunlight, so your light quality is uniformly good on the north, so you don't need to worry about that. You can actually probably have more windows on the north and have fewer windows or shade them on the south. This is where we like people to begin. So, and you can do this on a floor by floor level. You can do it on even a room by room level if you draw the rooms in.
Wow. That's awesome. So this is a just another decision-making tool for how you want the building to lay out at this point.
Yeah, yeah.
Another question real quick. Let's see. Is this limited to the American data only, or is the data on the model for the major countries around the world?
Oh, it's worldwide. Yeah, we have weather files for 5,000-6,000 locations and adding more all the time. If people have very specific locations and they have the weather, they can add it up too. So yeah, everywhere.
I like that.
So
cool.
This is where you would begin, right, with daylight. But let's say you have a value you want. Right, you're designing a classroom and the kids need at least 400 lux, not 300. Am I getting that? Sefaira will tell you that. You can set up numbers for that. Also, these are annual numbers, so they won't tell you if it's too bright at a certain date, at a certain time. So you can tell us what date and time you want, and we'll tell you exactly how much light you get there, which will be a good.
Let's do that.
Yes, March 21st, 9 a.m.
Ah, I'm busy that day. This is not going to work for me. Wow, that was fast. Like compared to last time, I mean, that was like.
Yeah.
Is that because it's already done the full analysis, so it's just pulling specific data out?
Yeah. Because these analyses require it to do hourly for the year. This is just 1 hour.
That's cool.
Yeah. And this building, you don't want to be in here at 9 a.m. This is lit up like an alien abduction. Yeah.
That's awesome.
Yeah. Apart from that, we have a couple of other metrics, the daylight factor, which clients in the UK use a lot for compliance purposes, and direct sunlight, which is an interesting metric. It tells you where you get a certain amount of direct sunlight hours a day. So if you're designing a house and you want to know where not to put the TV, otherwise you get glare on it, or where you need to put the potted plant to get light, it'll do that.
That's cool. So I'll be honest with you on something. I mean, when I started to look at this, I was a little bit intimidated. The whole idea of performance-based design or daylight analysis, that sounds like kind of a scary thing, but I mean, that didn't hurt.
No.
Who are the people who, I mean, obviously this is a powerful tool. Who's the people who are going to use this? Who should be running Sefaira?
Oh, our goal is to put this on every architect or designer's desktop. Yeah, we like to think of Sefaira not as a tool, but as a toolbox. You don't have to use everything, but it'll tell you maybe one thing that's important to you in no time at all. So that's the idea.
That's great.
Yeah, getting that info at the right stage of design, I think, is pretty huge.
Yeah.
So what about, I mean, obviously this is simple. If somebody wants more access to those things that are happening where I'm perfectly happy staying on the surface, can somebody who's a little bit more in tune with this sort of design go a little bit deeper?
Oh, yeah. Yeah. So there's two parts to this, because we realize that you're going to be changing geometry at certain stages of design, but after that, the kind of questions you're going to ask are going to be, what is the best value of X? What is, I need to shade these buildings. So let's take this for example. You have all these windows on the south. We knew they were a problem. And you decided, well, I like where the windows are because that's where the rooms are. My option is to shade them. So how can I figure out what the right depth of shading is? Well, you could model physically in SketchUp 10 different depths of shading for each window and run an analysis. And that's a good way to go if you have a lot of interns.
That's a choice.
But there's a second place, there's a whole online portal for SketchUp for Sefaira, where you can go there and we will do these parametric analyses automatically and graph them for you and say, hey, after 4 feet, you're not letting in enough light, so your heating is going to go up. That kind of stuff.
That makes a lot of sense.
So our goal is to help you with this in concept, and then you can fine-tune your building even more, all the way up to like early to mid SD.
That's great. So if someone wants to get a hold of Sefaira or learn more about it, what's the best way to do that?
Sefaira.com.
Simple answer. Duh.
It's on something called the internet.
I've heard of that.
So we will tell you a lot about what we do here. We have a couple of products. One is even more detail, and that's for engineers. So if they're interested, they can go look at that here. So this is where you would go. Or if you just want to pop by and talk to us, we'll be at Greenbuild.
Okay.
Yeah.
That is November
8th and 9th, yeah.
coming up.
In
Where's
Boston.
In Boston. So if you're in Boston and want to learn more about energy analysis, it's a great spot to get a hands-on, face-to-face demo, learn more about this. I'll be there. You'll be there.
Yeah.
But we got to do it without Josh.
Be tough.
Anyhow,
Good luck.
we got questions. We're getting towards the end, so get your questions in. We do have a few of them here. Can you make architectural details with this tool?
I'm going to understand this in two ways. Can you make detailed architecture with this tool or an architectural detail? Now, if you mean an architectural detail like shading or crown molding or something like that, which might shade the building, yeah, and you can do that without actually using too much detail. If you want to know how detailed you can get with this, you can zone this building. All of this happens in the online portion, but you can add rooms, you can set up rooms differently, so each room could have a different function, have a different number of people in it, just all kinds of stuff in the building. Our goal is to simulate, to represent the reality of your building as closely as possible without having to draw too much. So yeah, you can go all the way to a building that has individual rooms and analyze it at that point.
Yeah, we stayed pretty high level, but you could get more detail.
Yeah.
And if this person is new to SketchUp, perhaps, we don't know that, maybe they're asking about SketchUp's abilities to model it. Of course, you can model whatever you want, any detail you want.
Right. The idea with what Hari was showing specifically is taking a preliminary design, just the general shape of the building, and running energy design on it there. Of course, that model could then be used to create the full actual architectural model that we would move forward with once we have the design perfect.
Yeah. Yeah.
All right. Another question came in about step-by-step guide for users. How much, basically, I guess looks like training type information. What do you have available?
So we have demo models that you can try out. They're all of the same kind of detail, which is what you need to start with. So that takes exactly to where your building would have to be. There are step-by-step guides. There is actual training by one of us, and there is also self-learning stuff that doesn't have to do with a model, but in general. everything from building physics down to what does this button do?
And all of that's available through Sefaira.com.
Yeah.
All right, so that'd be a great place to go if you are looking for that information or adding that information to your repertoire of performance-based design tools.
Yeah.
Another one there. Can it generate reports for permit approval?
Wow. The answer is no. And that's because that's not what it's for. We are a design guidance tool, not a compliance tool. So you will use us when you're designing, which is like sketching. But compliance happens when everything's done and it's just a snapshot, it's like a photograph. Right? You're not making any decisions there, so we're not interested at that point.
So it's a tool that'll point you towards a design that will satisfy permitting, but it itself is not going to say, here's what you need to get your permit.
Yeah.
Okay.
Yeah.
Makes sense.
Uh-huh.
Can we analyze the temperature for the how much ton of an AC will be required? So, okay, I understand that question. So,
Affirmative. So you
Yes.
tell us what the temperature is that you want to maintain in the space, and then we'll tell you how much AC you need for that place and that building type and stuff like that.
okay.
Yeah.
So yes.
It does that.
All right. Well, unless any other questions come in the last few minutes here, I want to say thank you. Thanks for coming by. That was really cool. Like I said, I was concerned about that, but that seems very. I mean, all the heavy lifting is done for you. That's pretty awesome.
Uh-huh. And it works in SketchUp where it's easy to model. That was so hard when there was no SketchUp.
Oh, dark ages. All right. Well, thank you very much. Again, if you guys do have additional questions, throw them in on Facebook. We'll be on there for a little while. If there's specific information you want, or you want to learn more, like Hari said, come to Sefaira or come to Greenbuild. Squeak another question in there.
All right, what do we got here? Can you create PDFs with graphs or charts of the information Sefaira generates?
Yes, both. We will give you spreadsheet information of the stuff that you want, and you can visualize it any way you want, or we will give you graphs of certain things that you can just use directly.
So pictures or numbers, depending on what you actually want.
Yeah, sometimes both.
Ooh.
Yeah.
All right, that's the deluxe version. Pictures and numbers.
Yeah.
All right, well, I mean, you feel good? You got everything, showed everything you want to show? I don't want to cut you off.
I could just go on and on, but no. But yeah, thank you. Thank you for having me.
Thank you.
Thanks,
All
Ari.
And thank you guys for joining us.
See you next time.
Bye.
Bye.